Good morning, grade sevens. Question number one of what should I be able to do? Page 168 of Math Makes Sense 7 says draw a large circle without using a compass. Explain how to find the radius and diameter of the circle you have drawn. So I'm going to show you one way that you can do it, which I think is, to me, seemed most logical. Okay, you can see here I've got a soup can. Okay, it's got a circular bottom, so I'm just going to trace it so I know I can get a good circle. Use a Sharpie so you guys can see well. Okay, there we go. Stage one, I just drew a circle. I just traced it. So I got a nice circle. Now, I have to find the radius and the diameter. To do that, okay, I need to find the center of the circle. So I'm going to cut my circle out. Put this out right away. Dramatic television, I realize. Okay, now I have my circle. Now how can I find the radius and the diameter? Well, I know that the diameter is going to go straight through the middle of the circle, so I'm going to take my circle and I'm going to fold it onto itself into half. Okay, and it makes a crease. Now, I don't need to do this, but for you guys, I'm going to do it just so you can see better. I'm going to take my Sharpie. I'm going to highlight this line so you can see where the fold is. So there's the fold that way. So now all I got to do is fold it any other way. It could be like this, but I'm just going to I'm going to fold it pretty much the opposite way. So now I've got another fold. And again, I will highlight the fold so it makes it easier for you to see. Now you can see where this is the diameter. This is the diameter, although it should go all the way to the edges, but I didn't want to draw on the desk. So now we know where they cross, okay, it's got to be the center of the circle. So now to get the diameter, all I've got to do is measure across from this side to this side, and that is 9 centimeters. So right there. So I know that the diameter is 9 centimeters, and of course the radius is halfway. So I know it's going to be 4.5, and when I measure, yes, is indeed 4.5 centimeters. So that is question number one of what should I be able to do. So question number two simply says, find the radius of a circle with each diameter, 12 centimeters, 20 centimeters, and 7 centimeters. So we've got each one drawn here, not to scale, but with the label. So 12 centimeters, 20 centimeters, 7 centimeters. And diameter, of course, is a line that runs from one side of the circle to the other side running through the exact center. So I've got them horizontally here. There's our diameters for these, and I've written out what they told us: 12 centimeters, 20 centimeters, and 7 centimeters. And of course, the radius is half the diameter. So, you know, the first one, and I've anywhere from the center, so from here to here, okay, is a radius. Let me draw this, get it nice and okay. Anything that's through the center, okay, there's another radius, okay. Anything from the center out, so it's half the diameter. Okay, but to calculate it, it's as easy as, it's 12 centimeters, okay, divided by 2. So the radius is 6 centimeters for the first one. Okay, and on that, it's 10 centimeters for the second, 3.5 centimeters. Just remembering always to put your units down, okay, so that, because if you just put, say, 3.5, it doesn't give the information, convey the information that you need. So for question 3, it's just kind of the opposite. A has a radius of 15 centimeters, and they want to know diameter. So the diameter is all the way across, so it's simply double. So 15 centimeters times 2, 30 centimeters, 22 centimeters times 2, 44 centimeters, and C, 4.2 centimeters times 2, 8.4 centimeters. So next question number 4, it says we have a circle with a circumference of 219 meters. And they want to know what the radius is. Well, you know, it would be, if we need to have the configure out how to use that or use the formula. So what is the formula for finding the radius? Well, let's see. I think we just kind of start at the beginning with a little sample that I've shown you in class many times. So we do know the one, kind of the first one we ever started with, circumference over diameter equals pi. Okay, this one just kind of intuitively makes sense. If you can't make sense and the others get confusing, well, you know that, you know what, the circumference all the way around the circle, of course, is going to be bigger than the diameter. So we know that it's 3.14 and then so on bigger. I'm going to use 3.14. Okay. Now the analogy that I like to use, the comparison, is 6 divided by 2 equals 3. Because I know for me this works, and for some of you this is working. But just a way, if you can't figure out your formulas, as long as you know this first one, you can figure out all the other ones. So in this comparison, 6 is in the same spot as the circumference, so it's kind of as the circumference. 2 is in the same spot as the diameter, okay. And 3 is in the same spot as pi, okay. And you know what? That makes sense to have, because pi is just a little bit over 3 anyway. So now we want to know, so we know that circumference over diameter equals pi. Well, what information do we have here? Well, we know pi because pi is always the same. And for us, we're going to use 3.14, and we know the circumference. So we're trying to figure out ultimately the radius, but first we've got to figure out the diameter. So diameter, okay. Well, the diameter in here, the formula for diameter is diameter equals circumference divided by pi. And if you see up here how that might make sense, you go, well, the diameter over here is 2. You look at 2 now. And I've got 6 and 3 left. What can I do to 6 and 3 to make this work? 6 times 3 is 18. That's not going to work. Okay, 3 divided by 6 would be 1/2. Only makes sense 2 equals 6 over 3. Now you can see there's the diameter. Okay, 6 up here was our circumference. Okay, and then we have pi. So we know that's right. So for this one, we've got diameter equals circumference over pi. Well, we know the circumference, 919 meters, and for our calculations, we're going to use 3.14 okay, for pi. This should give us the diameter. So I'm just going to use my calculator and I got that equals 69.75 meters. Okay, but the question didn't ask us for the diameter, it asked us for the radius. So how can we get that? Well, okay, the radius is half of the diameter. So all we have to do is radius equals 69.75 divided by 2, which equals, I've rounded this off, so yours may be just a tiny bit different, or you might have used a higher degree of pi. Okay, but I'm going to say equals 34.875 meters is the diameter. Okay, and that is question number 4. Okay, so question number 5 says, a circular pool has a circular concrete patio around it. What is the circumference of the pool? Number A. So A, well, the circumference of the pool, so we have to go back and, okay, we've got Circumference, what is our formula again for circumference? Okay, well, circumference equals pi times diameter. Okay, and then back to our other thing, 6 equals 3 times 2. Okay, back to question 4, our little explanation. So we got circumference, we don't know the circumference, but we know pi, so circumference equals 3.14, and the diameter of the pool is all the way across is 24 meters. Okay, so we got 24 times 24 meters. So the circumference of the pool, okay, is, depending on how I rounded my pi to 3.14, so I get 75.36 meters. Sorry, put centimeters there. So that's all the way around. Okay, all the way around here. Okay, but now there's this concrete patio. Okay, it's around the edge, and it says, what is the combined radius of the pool and patio? Well, they're asking radius, so if we look here, we see we have a diameter here of 24 meters, so we know the radius of the pool is going to be half of 24, which is 12 meters. But see, we have another 2 meters. So for B, okay, and this was A. For B, we have, what is the combined radius of the pool? Well, it's 12 meters plus 2 meters equals 14 meters. Okay, now for C, it says, well, what is the circumference of the outside edge of the patio? So that means the circumference of all the way around the circle here. Okay, well, the information we need to get the circumference, well, we'll say the circumference equals pi, 3.14 we're going to use, times the diameter. Well, what is the diameter? So, well, the diameter from here to here is 24, but we know, okay, this space here is 2 meters. This space here, also 2 meters. So to go all the way across, it is 28 meters. So we got 28 meters. Okay, and if we multiply that together, we get, depending on how you round it off, get 87.92 meters is the circumference. And that is question number 5. So question number 6 says, Mitra and Mel have different MP3 players. And it says, the circular control dial on each player is a different size. Calculate the difference of the dial and on each MP3 player. So A, Mitra's dial, diameter is 30 millimeters. So here is Mitra's dial, and I forgot to write Mel here. This is Mel. So we want to get the circumference. Well, we know circumference equals pi times diameter. Okay, so that's 3.14. This is for A. 3.14 times 30. My calculator here. Equals 30 millimeters equals 94.2 millimeters. Again, you may be using a different pi, so you might get a slightly different answer. Okay, but now we got Mel. So what we see about Mel's is, okay, well, it's got the radius, and to do, so circumference equals pi times diameter, we need to get the diameter. Okay, so first thing we need to do is find the diameter of this. Well, if the radius is 21 meters, okay, we know that that the radius would go if it's all the way across, okay, radius would be double. Sorry, that should have been millimeters. So now let's just actually erase this, so we don't have to worry about that. So I've got 42 millimeters. So now we basically have we basically have the same problem. So now we can go for B. For B it says Mel's dial radius 21 millimeters. Well, we know now we're going to say it's 42 millimeters. So pi times 42 millimeters equals 3.14, okay, times 42 millimeters. And again, just 3.14 times 42 equals 131.88 millimeters. Okay, and it says, can you explain the difference? Well, once you have both of the diameters, you know that the ratio between the relationship between the diameter and the circumference is, it's about a little over 3 times bigger, pi. So if something has a greater diameter than the other one, it's going to have a larger circumference. That's just always going to be the case. Okay, that's number 6. So for number 7, it says on 0.5 centimeter grid paper, and I don't have grid paper, so I've just done an estimation on the board here. Draw 3 different parallelograms with area 24 centimeters squared. What is the base and height of each parallelogram? So in this example, I have just, to start off with, I've just done 3 rectangles, okay, which are also parallelograms. So we've got, on the first one, we've got a base of 24 centimeters and a height of 1 centimeter. So 24 centimeter times 1 centimeter equals 24 centimeters squared. Okay, so that's one opportunity. Now I've got this next one. I've got a base of 12 centimeters and a height of 2 centimeters. So we've got 12 centimeters times 2 centimeters equals 24 centimeters squared. Now I'm down here, final one using rectangles. I've got 8 centimeters, which is the base, times 3 centimeters, which is the height, 24 centimeters squared. So in this case here, from here to here, that's 3 centimeters is the height. Height here, 2 centimeters, height here, 1, and then the base. Okay, so that's when the parallelogram is a rectangle, but now I'm going to do some examples where the parallelogram is not a rectangle. Okay, so here is question 7. I've got 3 parallelograms that are not rectangles like the last one. Okay, so we've got, and they all need to have the area equal to 24 centimeters squared. So we got A here. You can see, so now these are a little different. This length here, okay, is 5 centimeters. This length here is 6 centimeters. And from here to here is 4 centimeters. So we need to figure out, so the area of a parallelogram, the formula is base, scratch that. Area equals base times height. So in this case, the base is here, 6 centimeters. And this is where some people get confused, so we're going to multiply. Okay, we got 5 centimeters and we got 4 centimeters here. Okay, so it's the height, okay, not this side length, okay, it's this right here. The height from the one parallel side to the other parallel side. So times 4 centimeters equals 24 centimeters squared. Okay, and then just quickly for B, 4 centimeters on this side, 8 here, 3 here. Well, we don't need to worry about this one, okay, because that's not the base or the height. This is the base. The base equals 8, okay, and height equals 3 centimeters, okay. 8 centimeters times 3 centimeters is 24 centimeters squared. And likewise, the last one, ignore this, okay. This is the base, 12 centimeters, and the height from one parallel side to the other parallel side. Okay, and that is 2 centimeters. So 12 centimeters times 2 centimeters equals 24 centimeters squared. So that's how you do that one. So for number 8, it says the window consists of 5 pieces of glass, and I've redrawn it here. Each piece that is a parallelogram has a base 1.6 meters. What is the area of one parallelogram? Okay, so so we got the parallelogram. So this from here to here, kind of see from here to over here, 1.6 meters. So that's the base. So we know the parallelogram, base times height equals area. So we've got the base as 1.6 meters, and then the height, okay, I haven't drawn the height on here yet, but from here to here, okay, says it's 2.4 meters. So we got 1.6 meters times 2.4 meters, okay, which equals 3.84 meters squared. Okay, so that's it's like this area in here, this area in here, this area in here. All those areas are 3.84 meters squared. So I'm actually going to write that in there just because 3.84 meters squared. 3.84 meters squared. 3.84 meters squared. Okay, so on B, it says the base of each triangle in the window above is 0.8 meters. What is the area of one triangle? Well, okay, and you have to remember our formula, okay, that the area of a triangle equals base times height divided by 2. So in this case, the base is 0.8. We multiply that by, so 0.8 meters by 2.4 meters. Okay, and then we divide it by 2. We get 0.96 meters squared. So in here, 0.96 meters squared. So that means over here, the same, 0.96 meters squared. So part 2 says, what is the area of the window? Explain how you found the area. Well, I kind of went above and beyond in the last one, so we can see each parallelogram is 3.84. Okay, and each triangle is 0.96. So I just had to add them all together. So I'm not going to add them up for you, but the answer comes to be 13.44 meters squared. Okay, that's number 8. So for number 9, it asks us, and again on grid paper, I've just drawn them here. On 0.5 centimeter grid paper, draw 3 different triangles with area 12 centimeters squared. What is the base and height of each triangle? So I've got 3 here. The first one, I've got a base of 6 centimeters, a height of, draw my centimeters in here, 4 centimeters. Okay, so 6 centimeters times 4 centimeters equals 24 centimeters squared, but we have to divide by 2. There's up here is the formula for area of a triangle. Divide by 2. Okay, so it's 12 centimeters squared as they're asking for. This one has a base of 8 centimeters, a height of 3. This one a base of 12, a height of 2. Same. Okay, and then in B it asks us, how does this relate to the triangles, the parallelograms in question 7. Okay, well, just wait for the bells again. Okay, question 7, okay, these are exactly half because these are the same base and the same height, but we divide by 2. And you can see an example down here. I've drawn a parallelogram, okay, on the outside edges, It's got the base, okay? We've got the base here, okay? We've got the height, which would be there, okay? And it would be the same for this as a parallelogram or this as a triangle, but then it would be double. It would be just in half because this is the same as this side, okay? They are congruent triangles, the same. Okay, that's number 9. So question 10, Po Ling is planning to pour a concrete patio beside her house. It has the shape of a triangle. The contractor charges $125 for each square meter of patio. What will the contractor charge for the patio? So let's just, so we've got, I've redrawn the thing. So it's $125 per meter squared, okay, of concrete. So now when you buy concrete, okay, usually you have to buy like a whole yard. So, but first let's get the area of the triangle. So we've got the area equals base times height divided by 2. Well, we see here the base actually, just because it's on the side here, this is still the base. So here's from here to here is still the base. So we've got so the area equals 4.5 meters. So that's the base, and then the height is also 4.5 meters. You can see the height to the tip of here, okay, times 4.5 meters. And then we got to divide it by 2. And I'm just going to go and skip right to the answer because you guys have your calculators or whatever. Okay, and it works out to be 10.125 meters squared. Now, as I mentioned, usually when you get it by a contractor, they don't sell you like 0.125 meters. You get 1 meter, 2 meters, 3 meters, whole number of meters. So if that's the case, it's going to be 11, okay, times $125, which would be $1,375. Okay, that's what you'd owe. Now, if you do have a nice, maybe you got a nice contractor and he goes, oh, okay, I'll just charge you for what I have. That would be 10.125 times $125. Okay, and that would equal $1,265.63. Okay, that's question 10. So here we have question 11. A goat is tied to an 8-meter rope in a field. What area of the field can the goat graze? Okay, well, we know. So basically the goat is tied to maybe to like a stake in the middle, and he can go 8 meters this way. So that's 8 meters, 8 meters. So basically that means that the radius, okay, make this a bit bigger, that the radius equals 8 meters. And because we're going to leave it later, the diameter is all the way across would be 16 meters. Okay, so it says what area of the field can the goat graze? Well, we know, okay, area of a circle equals pi r squared, which equals pi, in this case, times 8 times 8, okay, which equals 200.96 meters squared. Okay, so that is the area of the circle that he can do. But it also asks what's the circumference. Well, circumference equals pi times diameter. Okay, and so we know we've already just made that step up here, so it's 3.14 times 16. Be careful not to make it 8. Okay, and we get an answer of 50.24 meters. Okay, so this actually should be meters, and that should be meters, meters. Okay, as long as we just really make sure your answer. So circumference is always in units, area is always in units squared. Okay, that is question 11. So number 12, it says choose a radius, draw a circle. So I chose, it's actually where it says A here. I chose that's my circle, and I chose a radius of 4 centimeters. Then it says, suppose you divide the radius by 2. So I did that, and I draw the circle over here. Although I suppose maybe I should have done it more, like to take this, okay, put it here. And check out, there we go. Let's say, okay, another way to do it. Anyway, it says, suppose you divide the radius by 2. What happens to the circumference? Well, I kind of felt the easiest way was just to do the circumference. So on the first one, we know that circumference equals 2 times the diameter, or 2 pi r. Same thing. Okay, so for this one here, for circle A, the first one I drew with a radius of 4 meters, okay, it's 2 times 3.14 times 4. Okay, and then we do that 4, that makes it 8 times 3.14, and it comes up with 25.12 meters. Okay, remembering, so that's the circumference of A. Now we half it, so I'll use this one over here, it's easier to see. 2 meters. Okay, what happens to the circumference? Well, we know it's going to be less, but how much less? So we're going to half the radius, so let's see. So if we go circumference equals 2, I'm just going to say the diameter. We know the diameter is 4, okay, equals pi times 4 equals 12.56 meters. So when we cut the radius in half, we cut the circumference in half. So if you cut the radius by half, you cut the circumference. Okay, so it's exactly the same ratio. Now the next part of it says, what happens? Explain what happens to the area. Well, let's do the area of the first one. So we got, and the area equals pi r squared. So for the first one, it's pi times 4 times 4. Okay? And that equals 50.24 meters squared. So important, remember, area is always units squared, circumference is just units. So now we've got, that's the area of the first one. Now what about this one with the radius of 2 meters? Area equals pi times 2 times 2. Now look at the ratio here, 4 times 4 and 2 times 2. Okay? And we get an answer of 12.56 meters squared. So if you look at the ratio, what do you see between here? What's the connection between 50.24 and 12.56? Well, if you look at it, you can see this 4 times, 50.24 is 4 times 12.56. So if you cut the radius by half, then you cut the area by a quarter. Now it makes sense. Now look here, say when we had 4 here, and we have 2 here and 2 here. Okay, 2 times 2 and 4 times 4 is 16 is a quarter. Now say I chosen a different, and say this wasn't 4, but this was 6, and then this was 3, and this was 6, and this was what? 6 times 6, okay, and then 3 times 3, so 6 times 6 is 36, 3 times 3 is 9. 9 is 1/4, okay, of 36, okay, so that is number 12. So question 13 says the diameter of a circular mirror is 28.5 centimeters. So I've drawn a circle to represent that mirror on there with a diameter of 28.5 centimeters. What is the area of the mirror? Give the answer to 2 decimal places. Well, okay, we've got the formula for area of a circle is pi r squared. Okay, so pi times r times r. And in this case, it's got the diameter. So diameter equals 28.5, but the radius is going to be half of that. So that's 14.25 centimeters. So now that we know the radius, we're going to find out, so the area is 3.14 times 14.25 times 14.25. Okay, and then you work that, and when you multiply that out, you get to 2 decimal places, depending on what you use for pi, 637.62 centimeters squared. And that is number 13. So number 14, suppose you were to paint inside each shape below. So I've drawn the shapes on there for you. Which shape would require the most paint? How did you find out? Well, the paint, that's going to be the area. So you got to find out the area of each one. So, so I did A, B, C. So a circle is pi r squared. So we've got pi, and its radius is 4.2 centimeters. So pi times 4.2 times 4.2 equals 55.39 centimeters squared. So units squared. I could have also written centimeters in here, but for the math I didn't bother. B, area of a triangle is base times height divided by 2 equals a base of 12 centimeters, so of 12, height of 9 centimeters here, times 9, and then divided by 2. So that works out to be 54 centimeters squared. Okay? So C, we have a parallelogram. Area equals base times height. So the base is 7 centimeters, and the height 8 centimeters. So 7 centimeters times 8 centimeters, 56 centimeters squared. Okay, now since they want to know which requires more paint, which requires more area, well, looking at this, they're all pretty close, but the parallelogram is 56 centimeters squared, has the greatest area. So it requires the greatest amount of paint. So question 15, the results of the student council election are displayed on a circle graph. 500 students voted. The student with the most votes was named president. Which student was named president? How do you know? Well, looking at this the student graph, you can look at the pieces of the pie, and just visually it stands out that Laura's got a larger piece of the circle than Jared or Jeff, so Laura has won. It also tells us in percentages that Laura has 56% of the vote compared to 28% for Jared and 16%. So you can tell right off the bat for A that Laura was named president just by those 2 ways. Then it says, how many votes did each candidate get? Okay, so Laura, let's start with Laura. Laura had 56% of the vote. What else do we know? We know that 500 students voted. So 56% of those 500 students voted for Laura. So now how do we figure that out? So we got 56%. Well, there's a couple other ways to write 56%. Okay, could write it as a fraction, 56 out of 100. We could also write it as a decimal, 0.56. So I'm going to choose the decimal, and if I go 500 times 0.56, okay, I'm going to get 0, 0, and then a 5. And we got a 0 because we're not multiplying by 5, we're multiplying by 50, so the 0 goes there. We got 0, 0, and then 5 times 5, 25. So now we have these 2 decimal points here that are just 2 numbers to the right of the decimal point, which means we need to take the decimal point that looks like it's here and move it over 2 spaces.
So 280 votes. Now, of course, once we do that, does that make sense? We decided Laura got over half the votes just by looking at it. It's 280, a little over half of 500. It is, so that makes sense. So Laura got 280 votes. So then Jared, he got 28% of the vote, so it would be 500 times decimal 28. Okay, I'm not going to do that calculation. You guys can use your calculator for that. Okay, so Jared got, that works out to be 140. Now looking at that, does that make sense? He got a little over a quarter of the votes. Okay, yeah, that makes sense to me. So that's for Jared. Okay, and then so let's just say Jared. That's Laura. And now we got poor Jeff, who came in third. Okay, he's got 16% of the vote. We got 500 times decimal 16, and that brings us, and if you work that out, comes to 80 for Jeff. Now that makes sense too. Now the last thing we can do is kind of add them up and see if it makes sense. So we got 280, Laura got 280, Jared got 140, and Jeff got 80. Now that should add up to 500. If it doesn't add up to 500, then we've made a mistake somewhere. So we've got zeros add up to 0, 8 and 4 is 12, and 8 is 20. So carry the 2. 500 votes. So I'm feeling pretty confident that we've got the right answer. So C, write 2 other things you know from the graph. Well, I'm not going to write them, but we'll talk about them. So like I said, I know that, for example, just looking at the graph, that Laura got more votes than Jared and Jeff combined. I know that I guess I was going to say over half the votes, that's the same. I know that Jared got a little over a quarter of the votes. I know Jeff got less than a quarter because I can see visually from the graph. So that's number 15. So question 16, circle graph shows the surface area of the Great Lakes. So then I've recreated the circle graph on this page for you, and it says A, which lake has a surface area about 1/4 of the total area? Well, 2 ways to kind of do it. Circle graph has that nice visual representation, so at a look, I see Lake Michigan and Lake Huron are pretty close, but upon further investigation, and just also to the eye, I can see Lake Huron has a surface area of 24%, which is really close to 25%, 1/4. So Lake Huron, for A, is the lake with a surface area about 1 total. B, it says, explain why Lake Superior has that name. So here's Lake Superior here. It's got a surface area of 34% of the Great Lakes. Okay, as we look around, it's the highest percentage, so it's got the greatest surface area of any of the Great Lakes, hence the name Lake Superior. And finally, for C, I'll do this one on here, says the total area of the Great Lakes is about 244,000 square kilometers. Find the surface area of Lake Erie. Okay, so we need to find the surface area. Well, if it's the whole thing is that, like Lake Erie says it's 11%. So 11%, again, can be written as 11%, which can be written as 11 over 100. And as a decimal form, is decimal 011. I think the easiest one to do is the decimal. You may feel differently, and that's okay. 244,000 times decimal 11. Okay, and let's see if I can move that out of the way for a little bit here. So I know that 1 times 244,000, okay, is 244,000, and then I just have to do it again. So I put a 0 because we're by 10, okay, and then we've got 244,000. Okay. 0, 0, 0, 4, 8, 6, 2. Now again, we haven't dealt with these decimals, so that there's two numbers to the right of that decimal, which means we need to move these over again. So we got an answer of 26,840 square kilometers for Lake Erie. That's question number 16. Okay, question 17. I've got says this table shows the approximate chemical and mineral composition of the human body. Water 62%, protein 17%, fat 15%, nitrogen 3%, calcium 2%, other 1%. Draw a circle graph to display these data. So I've got, first off, I know I put these data over here. So we know how, when we've done this in class before, we take 62%. How do we make that translate that to be able to draw it on a circle graph? Well, remember we've got different ways. So we're going to use let's go over here. Sorry, I just changed my pen here. I'm going to start with up top here. I'm going to say 62%. Now we've talked even today a few times as a fraction that can be written as 62 over 100. As a decimal, 0.62. And for this, I think for me it's easiest to do as a decimal, so that's what I'm recommending. So in this chart, I've got the 62%, and then how I write as a decimal, and then how do we make it into degrees? Well, how many degrees are there in a circle? Okay, 360 degrees. So we're trying to, if we multiply the decimal version of the percentage, in this case 0.62 times 360, we'll end up with the amount of degrees. So we have here 0.62 times 360 equals 223.2 degrees. Now, you're going to do this with your protractor. For those of you who need help, I can help you in class. But I'm going to start along, okay, this line right here. I drew this kind of like a radius first, and then I go, and then I use a protractor to figure out what is to get to 223. Well, I know it's across to here, right over to here, it's going to be 180 degrees. It's half the way around. So then I have to go another 43 degrees, which is what this is. So this one in total is 223 degrees. And I know it's 0.2, okay? But, okay. Then the next one, 17%. As a decimal is 0.17, right here. Times 360, because that's how many degrees in a circle, we get 61.2 degrees. Okay, and this angle right in here, 61.2 degrees. Okay. The next one, 15. Okay, 0.15 times 360 is 54. So this is 54 degrees. Okay, and then this one, these ones are a lot harder to see. Okay, the next one is 3%, which translates to 10.8 degrees. Okay. And then we've got 2%, which is 7.2 degrees, and 1%, which is 3.6 degrees. Okay, so what you'd have to do is put your compass here, and figure out 223. Once you do that, now you put your compass along this line, and you're trying to get an angle. You're going over here until you get 61.2 degrees, or just 61 degrees probably with your compasses. Same thing, and once you do that, then you're going to use this line. And you go 54. Okay? Then once you have it, I mean, I've got some circles and stuff in there, assuming I've got all this. Okay, then you can maybe color in your different things. Okay. Okay. Different circle graph. Let's go there. Oops. Anyway, you get the picture. So that's what we do, and I can do that with you in class if you're not sure how to do that using your protractor. Okay? Anyway, that's question number 17. Oh, no, it's not. That's the circle graph. Sorry, then B. Jensen has mass 60 kilograms. about how many kilograms of Jensen's mass is water. Anyway, so sorry. So for that was A. So for B, it says Jensen has mass 60 kilograms. About how many kilograms of Jensen's mass is water? Okay, so right down here we got Jensen. So Jensen, mass of 60 kilograms. Okay, and it wants to know how many kilograms of Jensen's mass is water. Well, we know, looking at our circle graph and at the table, that 62% of the human body is water. So it makes sense to say that 62% of 60 kilograms will be how much water of Jensen's mass is water. So we do 62%. So we're going to change that to a decimal. Decimal 62 times 60. Okay, so that's 0. So 0 times anything 0, so I don't need to do that. So I've got a 0 here because this is times 60. 6 times 2 is 2. Carry the 1. 6 times 6 is 36. 37. And we have to move this decimal over 2 places because of there. So we need 37.2 kilograms of Jensen's mass is water. So that is question number 17. So question 18 is, here are the top 10 point scorers in the 2006 Canadian Women's Olympic Hockey Team. The table shows each player's province of birth. So Manitoba has 1 player, Saskatchewan 1 player, Quebec has 3, and Ontario has 5. Question A says, what percent was born in each province? Well, there's 10 total players. So you can see on here I've written Manitoba has 1 of the 10. So 1 divided by 10 is 10%. Okay, and so 10% I have converted to a decimal of 0.1. This is also, Saskatchewan also has 1 out of 10, which is 10%. Quebec has 3 out of 10, which is 30%, as 0.3 as a decimal, and Ontario 5 out of 10 or 0.5, 50%. Okay, so now if we go over and we want to draw a circle graph, okay, well, one of the first things that we can do, okay, is we can just figure out whichever strategy to divide your circle, and radius, diameter right through the middle. Okay, and because 50%, which is 180 degrees, we already know this. I didn't have to work this out. Okay. Okay, is Ontario, 5 out of 10. So here I can write, change my color. Ontario, 50%. Okay, so now from here we've got over here our different degrees that we've got. So we had Manitoba as a 10% as a decimal was 0.1. We multiply by 360 degrees to get 36 degrees, which makes sense. 10% of 360, 36. Same for Saskatchewan, 36 degrees. Okay, Quebec is 30%, decimal 3, and it's 3 times as much as 36, so 108 degrees. So if we put our line back in here, so you're going to use your, I think I might call it a compass, but it's your protractor that you're going to use, okay, so I'm starting here at 0 degrees. Okay, so from 0 degrees, you can see up the top there, I need to go to, there's I'm at 90. Well, I'm trying to get to 108. I want to do Quebec next. So after 108 from 90, I need another 18 degrees. So 90 minus 18. 72. Okay. Okay. So now I've got the next part of my circle graph, and it is Quebec. 30%. Okay, so now we've got, and we have to just do one more in here. So now we've done 50. Okay, now so we got to get 36%. So this should be 32 degrees. So I'm going to go here and I'm going to start at 0. I just go up to 36 degrees. And that gives me the split in there. Okay. And I'll go gray. Here. And I'll go light blue. Okay. So now I can go in here. These are the same, but it's Saskatchewan. So I'll put oops, sorry. Got this fill thing on still. Let's take that off. So I've got 10%, 10%. So we'll say here, not for to write it in there, so we'll say Saskatchewan and Manitoba. So there's our circle graph. So to display the data in part A, it says, and then C says, why do you think more of these players come from Ontario than from any other province? Well, there's other factors. You could think of weather. Who has the coldest weather? They could be playing outside. But Quebec, Saskatchewan, Manitoba, and Ontario all have colder climates that freeze in the winter for that. So maybe that's not it. They could have different infrastructure, but you know what? From a statistical point of view, Ontario has the most amount of people. So that makes sense that they would have the most amount of players on that. So that would be my guess. Anyway, that's all these. So the finished of the what should I be able to do on page 168 to 170. All right. Thanks.